Hi everyone and welcome to this talk. First of all, let me thank you all for watching this. I also want to thank RubyConf for the fantastic organization. Harness the power of functions to build composable RAG applications. We're here today to talk about Webpipe, a thin abstraction on top of RAG. As the title says, it allows us to build applications that can compose. We'll see in a moment what it even means. Besides presenting Webpipe, today's topic is aimed at those interested in functional programming. This talk should also help to distill the different actors playing together in a complete stack. We'll see how to build applications with a better architecture. To begin with, we'll start with some basics about functions. Next, we'll move into RAG and its design model. Then we'll jump into Webpipe and we'll walk through its main features. Lastly, we'll see it integrated into the context of the Hanami framework. Before diving into the content, let me briefly introduce myself. I'm Marc Busqué, and these two are my sons and meaning of my life. I'm a software engineer working mainly with Ruby since 2013. I'm working at Nebulab, the primary maintainer of the Solidus e-commerce platform. By the way, we are hiring and, believe me, it's one of the places where you'll find a better work culture. I'm also a member of TryRB and Hanami, and I try to put my 2 cents moving them forward. Alright, let's begin by asking a question. What is a function? No secret, a function is an opaque box that takes an input, does something with it under the hood, and gives back an output. In more mathematical terms, a function is a binary relationship between two sets, where each element of the input set is matched precisely to one element of the output set. For example, we can talk about a function length. This function maps every possible string in the world to an element of the set of integers. Of course, when programming, things get more complex. This example is an instance of a pure function. We can give 1000 times the same input to it, and we'll always get the same output and nothing more. But in computing, we always end up having to deal with two uncomfortable guests: hidden preconditions and side effects. Let's say we want to know the stock for a product in a given store. The same execution could return different values over time if the stock changes. On top of that, it could be modifying a counter of the number of visits. In one of the most basic and common approaches, we capture these hidden preconditions and side effects in the snapshot of the current database state. Still, using functions as a fundamental abstraction when programming is beneficial. To complete the picture, we need to talk about the star feature of functions: composition. Two functions compose when the output of the first belongs to the same set that the input of the second. In that case, we can squeeze both functions and treat them like a single one. For instance, the length functions we saw before goes from string to integer. Then another function greater than 4 goes from integer to boolean. We can compose both into a function longer than 4 and go straight away from string to boolean. In a way, programming can be seen as composing functions. We are going from an input to an output, and we do so by using camouflage functions disguised as methods, modules, and objects. There's an interesting type of function composition, and it's that of functions with the same type for the input and the output. These types of functions compose an infinite number of times with themselves. For instance, the function that adds 1 to an integer can be applied an infinite number of times recursively. Let's now move on to RAG and let's see if what we have discussed makes any sense in this context. As you probably know, a RAG application is anything responding to a call method. For instance, this is a Hello World application on RAG using a Lambda function. As any other RAG application, it takes as argument the request environment and responds with a triplet of response status, headers, and body. That means that if we want to decorate a RAG application, we have two possibilities: modifying the request before it reaches the application, or modifying the response once it leaves it. This is another RAG application that decorates the Hello World we just showed. It adds something into the request environment, and it consumes it later to build the response. We can abstract the decorated application. Now it's an argument of the second application. However, as we know, to be considered valid by RAG, it needs to take a single argument. We can fix that by partially applying the function thanks to Ruby's current facilities. The resulting lambda is obedient to RAG's constraints. This is just another way to replicate the same behavior, usually done by the so-called RAG middlewares, like we are doing in this slide. Middlewares are just a convention. The decorated application is stored as the state of an instance. That instance is itself the final RAG application. Notice how we store the application on initialization, and then we also define the call method. That convention is so common that it has a built-in DSL in RAG. We use a given middleware and we run the decorated application. If you are a bit lost, don't worry. You can pause the video and think about it. Anyway, it's not going to be something essential to understanding the rest of this talk. But I wanted to show these different ways to build a RAG application because what I want to highlight is how it's implementing a two-way pipe model below the surface. Take a look at this example. Here we have abstracted the text that we add to the response. First, we use a middleware decorating with 1. Then we use another one decorating with 2. However, look at the response. The first middleware with options to modify the request is the last one capable of changing the response. This slide illustrates better the two-way pipe that RAG implements. That's close to function composition, but we're not there. A RAG application output is not the same type as the input, so they can't be composed. The best we can do is call one application from within another. And that brings us to the main topic of this talk, Webpipe. Webpipe is a thin layer on top of RAG. It transforms that two-way pipe into a one-way pipe built thanks to function composition. Look at the picture. We no longer have a distinction between the middlewares and the application. The only thing we have are functions. Each function is by itself a complete RAG application. The HTTP client is sending both the request and the response. The first function will receive a response that is empty. However, it's going to be built through the pipe until it reaches the client again. You write a Webpipe application by plugging functions that take and return the same data type. The type is an immutable struct containing the request information and methods to build the response. As we saw, you can compose an infinite number of these kinds of functions. That's a Hello World application written with Webpipe. We plugged two functions, two steps. The first one takes the connection struct and calls an addResponse header method on it. That returns a fresh new instance of the struct with the content type set. Then, the new struct is handed over to the render step, which creates the response body. If you're familiar with Elixir, you'll recognize this model as the same used by the plug library. It was an inspiration for Webpipe. In the last example, we defined the functions as blocks. However, they can also be given as methods in the same class. Another option is to use a dependency injection container to resolve the operations. We only need to specify the registration key on the step's definition. Here we are using dry container. If you don't know it, it belongs to the family of libraries within the dry-RB organization. Webpipe is designed to fit in the same ecosystem smoothly, as we'll see again shortly. Modularity is another core concept in Webpipe. By default, Webpipe features are bare bones. The connection struct only has attributes to retrieve what we could think of as the primitive of a web request and the methods to build the web response. There's also an add method to include anything to the struct and then consume it later with fetch downstream the pipeline. We also have a bunch of extensions, which add more everyday features. Then you can also easily create new extensions. Let's take a look at one of them. Parameters are just an abstraction on top of a URL query string or a request body. So, to have them in Webpipe, you need to load them first. After enabling the extension, a new params method is made available to the struct. In this example, we say hello to the username provided as a request parameter. We use the params method to fetch the name and add it to the struct. Then we consume it later in the render step. Notice how there is another change here. We have removed the content type method and instead we are using a built-in plug. Webpipe comes with a few of them for everyday operations. We can make the parameters more compliant with traditional Ruby conventions by having keys as symbols. For that, we need to use a built-in config plug that allows tweaking how some methods on the connection struct work. In this case, we configure the params extension to symbolize the keys. Under the hood, this extension uses Dry Transformer, another dry-RB library that helps streamline function composition. Here, we are applying some functions to the parameter hash. we are basically in a kind of fractal-like function composition situation, which is pretty cool. Now, let's stop for a second. There's some bit here that, in real-life development, we like to extract. For instance, we don't want to set the content type or configure parameters at every action of our application. But think about it. We're building Webpipe applications by plugging together functions that take and return the same type. If we look at the application as a whole from the outside, it's just an opaque box that also takes and returns a connection struct. Zooming out from the fractal, we can extract the common bits in a standalone application and then plug it as if it were just another step. So finally, we met the title of this talk. We are composing RAG applications. But we are not done yet. Let's go back to the design pattern behind Webpipe. Besides pure function composition, there's an extra feature that we need to consider. That's the ability to short-circuit the chain and return early from an intermediate step. Take again the example of saying hello to a given user. But now we are going only to authorize the greeting for some users this time. Our system only knows of two users, Alice and Joe. We add a new authorized step after fetching the name. If the name is known by the system, we keep going. Otherwise, we return an error and halt the connection struct. So, when the unhappy path is taken, no further downstream operation will run. In that case, the rendered plug is not reached. You're familiar with monads? That's Clasley composition. Maybe you're more familiar with railway programming. But if those names don't tell you anything, it doesn't make any difference to understand the concept. Let's move forward to other Webpipe features. We can include middlewares in Webpipe applications. To do that, we have the use method, which will add the given middleware to the generated RAG application. In this way, we can take advantage of the large ecosystem of RAG middlewares. In this example, we are combining the RAG session middleware with Webpipe session extension. When the name is given in the params, we add it into the session. But we don't need to provide the name again on the second call to the action, as the name is already in the session when we fetch it. Similar to what we did with plugs, we can bring the middleware from the base class. Or we can use a shortcut method composed to use and plug at once. Thanks to functional programming, we've been able to come up with a simple, powerful, and beautiful API. However, one of the beauties of Ruby is that its flexibility allows us to blend functional and object-oriented paradigms. Thanks to the latter, Webpipe comes with the option to inject plugs and middlewares easily. Here is how it works with plugs. We only need to match the plug name with the new operation when we initialize the Webpipe class. Notice how we substitute the render step with a custom implementation. Injection is very useful for testing purposes, as it allows us to replace heavy operations and speed up the test suite. So much for how Webpipe is seen in isolation. But can it be really useful? An actual web application consists of a set of responsibilities. How does Webpipe fit within the context of a web framework? Take Rails, for instance. As we all know, Rails implements an MVC pattern. You can see Webpipe as the C in controller. Rails router can dispatch requests to a RAG application, so nothing stops you from using Webpipe within it. It even comes with an extension if you need further integration, like rendering with Action View. You can check the docs for that. However, where Webpipe shines the most is in the context of a highly decoupled system. And that brings us to the last section of this talk, Hanami 2. Hanami 2 is a wholesale but assemblable application framework. At its core, it's a matrix made of DryRB components, Hanami libraries, and the ROM database toolkit. It's been made by beautiful people like Tim Riley, Piotr Solnitsa, Luka Guidi, and Nikita Shilnikov. Each of the Hanami 2 parts help make the whole, but they are replaceable by any other preference. Unfortunately, we don't have the time to go through everything that Hanami 2 provides. Still, I do want to show some snippets to convey how different responsibilities combine to build a full-stack application. Following slides belong to a basic to-do application you can find under my GitHub profile. Here, you can see the application route definition. The slice keyword creates a namespace and expects a sub-application within a subdirectory. With slices, Hanami helps to decouple user code. You can still have all the code within a single repo. You can deploy it all at once. But you also have a structure. As for the individual routes definition, the syntax should be familiar. The endpoints are keys given to a dependency injection container. They resolve to the Webpipe application that will be called. Let's take, for instance, the update of a to-do item. Webpipe is responsible for handling the request-response cycle, so it's the next actor in the chain. To begin with, it composes the main application within the slice. Let's jump there a second. This application configures the session through the RAG session middleware. It also adds CSRF protection and a handy flash mechanism. It also sets the content type. And lastly, it configures some data to be available in every template. That comes thanks to the Hanami View extension. Pay attention to the fetch entity by ID, this constant defined here on the top of the file. It's a higher order function. It returns a step that tries to find an entity from a given repository by ID, and halts when it's not found. Back to the update application. Looking at the plug definitions, it's pretty clear what it does. It fetches the to-do instance, it performs the required business transaction with it, and then it renders a response. We just saw how it delegated getting the entity to the repository. Now, let's have a quick look at the transaction. The transaction uses dry monads to bind together the individual operations that make it. Here we only need two operations: data validation and persistence. As for the data validation, it delegates to a dry validation schema. It defines a contract that the input data needs to obey. Secondly, it calls the repository to perform the actual update. It's a ROM repository, which for such a simple case almost requires no code. Back to the action. Let's stop on the transaction step. After calling the transaction, it pattern matches on the result. If it's a success, it goes on. However, in case of failure, it binds the returned errors, delegates them to the view, and halts the pipe. However, if we continue on the happy path, we reach the render step. Here it just sets a success message and redirects to the root path. Okay, that was a fast glance to Hanami 2. Hopefully you had the chance to glimpse the impressive improvement that it brings to Ruby in terms of architecture. Please check the repo if you'd like to study it more closely. As for our talk, we're already at the end. I just want to thank you again for watching it. You'll find the slides and the examples we saw in this repo. If you have any questions, please use the Discord chat, open a discussion on the Webpipe repo, or reach me personally. I'll be delighted to help. Bye bye!